Question 3 starts by testing your knowledge of alkenes and stereoisomerism, and then it moves into physical chemistry, and there's a enthalpy question towards the end of it. So it starts off with this lovely looking organic molecule, and we have to say what the functional groups are, the two functional groups present. It says name them, so we're not going to give the formula, we're going to give the name. So there's one I've highlighted in pink, so that's the alkene functional group, and this one here is the ester functional group. Why is compound I classed as an unsaturated molecule? And it's because it contains a carbon-carbon double bond. If you shake compound I with bromine, aqueous bromine, what colour change would you see? So this is obviously going to react with the carbon-carbon double bond, and the bromine will be decolorized. So from orange to colourless. Definition: compound J is a stereoisomer of I. Let's go quickly back up to here. This is in the Z orientation. So the stereoisomer of that would be in the E form, where this carbon change continues in that direction there. So we'll go back to the question now. What is meant by a stereoisomer? The same structural formula but different arrangements of the atoms or groups in space. So that's just got to be learnt, I'm afraid. And then I've already said this. So there's what the stereoisomer of I would look like. So that's J. And here it turns into an enthalpy change question. And this is testing your knowledge of calorimetry. So how do you know it's calorimetry? We've got a mass of water that's been heated. We've got some temperatures. We can work out the change, and we're given the specific heat capacity of water. So there are your clues that we're going to be doing some MC delta T stuff in a moment. Another definition: enthalpy change of combustion. Enthalpy change when 1 mole of a substance reacts completely in oxygen. Calculate the energy released in kilojoules in the student's experiment. So it's just the MC delta T part here we need. So M, the mass of water, was 50. C, specific heat capacity of water, is 4.18. And the temperature change, the delta T, came out at 33.8. That gives you that many joules. Remember, this comes out in joules, but they want the answer in kilojoules. It's the kilojoules at the end there. So we're going to divide this by 1,000. So 1, 2, 3, knock the decimal point back, 7.06 kilojoules. So how many moles of I was reacted? We're given the molecular formula, so we're going to need to turn that into an MR. How many moles? So it's mass over MR. That's 0.005. And then the enthalpy change of combustion. So the second part of calorimetry is the Q over the moles. The minus sign, remember, because this is an exothermic reaction. The water was heated up. So it's minus kilojoules over the moles. And we get minus 1412. Part 5. Student noticed that the compound I burnt with a yellow flame. So that means yellow flames mean it's incomplete combustion. The black smoke is soot, so carbon solid. Suggest an explanation. I've already said it. We've got incomplete combustion produces solid carbon. So that's explained the yellow flame and the soot. So some scientists, bit of green chemistry, a little bit I suppose, some scientists believe that we should use more biofuels such as biodiesel. Bioethanol is made from the fermentation of plant sugars such as glucose. Write the equation of fermentation. So this is just a recall question. C6H12O6 is the glucose. That'll make 2 carbon dioxides and 2 moles of ethanol. And then the final part, what are the conditions for that reaction? So you're going to need a yeast catalyst or zymase catalyst. It's got to be around about 37 degrees C. Actually, the mark scheme allowed 20 to 45, so it's quite a range there. I would always say to my students 37 degrees C is the temperature for fermentation, and it must be in the absence of oxygen or anaerobic conditions.